Now that you have the override toString method added to both of your derived classes, let's come over to the main method and I will show you an example of how polymorphism works with two objects that have a relationship and share a method, in this case toString, but the toString method has two different implementations. But we often want to write as little code as possible to solve the problem. So if I wanted to write out the toString for both a full-time and part-time employee, I could create a loop that looks for base class objects of employee and then be able to call the toString method for the particular objects inside. This also works for storing information about particular objects. So in our previous lesson, we learned about collections, and specifically we learned about the list collection. And we can make these lists out of not only our simple types, but we can make them out of object types. And so since both part-time and full-time inherit from class employee, if I create a list of class employee type, then I can add my employee objects regardless of whether it's a full-time or part-time object type, since they all call back to the employee type, right? Polymorphism is at its core having objects masquerade as something else. And so in this case, our full-time and part-time employees are masquerading as employee objects. I can then loop through using a for each with this list. And using the emp of type employees, since that's the type that I have in my list, I could call the toString method. Now, toString belongs to every object that is ever created because it's part of the object base class, which is part of the .NET framework, and ultimately every class ever created has a relationship with the object class. But like I said, by itself, the toString implementation doesn't really help us. All it does is output some information about the name of the class, unless you've done what we did and override it with your own implementation. Now, since both our full-time object and part-time objects have implementations for toString, we can then use one loop and one statement to print out for all types of employees as long as they share a base class. So I wrapped this toString in a write line so that we can see this output in the console window. So go ahead and run your application, and what we should see is our first object, John Smith, is full-time. So we know that the compiler has identified the fact that it's a full-time employee object, although it was residing in an employee list, and that we can see Sarah Jones is a part-time. We know that it's calling the appropriate toString for each derived object type, although we're making it kind of masquerade or polymorphically work as its base type. And part of this has to go back to the fact that CLR, which is our underlying runtime for .NET, it always knows what type an object is, regardless of how we are kind of polymorphically playing around with it. Underlying, in the system, you can't fool it. It always knows what type an object is. But this way, we can have all different types of employees. Maybe we have seasonal employees, we have part-time, we have full-time, we've got hourly, we've got salary. It doesn't matter as long as they all have a same base class. We can store them in one list, and we could use one loop for accessing them. And that really is the foundational idea behind polymorphism, to help make our code easier and access to that code easier. So through this next section, learning about some advanced OO concepts, I'm going to continue using this little code example that we've written as I get into some of these other topics.